I'm Melanie Wise, and this is Tully Foot, and we work at Willow Garage. We're software developers for Ross. Sorry. Sorry. And what we've been working on recently is we're trying to make a sub $1,000 robot. We're calling it the TurtleBot. If you know Ross, we have an obsession with turtles. And basically, it's your standard iRobot Create with some laser cut platters on top of it, a sub $500 computer, or around $500 computer, and right now we're using a Prime Sense, but in the future we plan on using a Kinect camera, so Microsoft Kinect, everyone's seen it. And what we're doing with that is we're faking laser data, and we're doing navigation. And Tully's going to talk to you about that while I drive the robot around. Okay, awesome. So we've tried to make some cool tools for this robot, including a dashboard and other things to help you debug. It's kind of like a small version of the PR2. Most of the software that we use on the PR2, we also have the ability to use on our little TurtleBot, so there's a lot of portability. We did the same thing for the NXT robot also, if you guys saw that. And so we're just trying to make robots more accessible and give people a chance to really dig into ROS and use it and have fun with robots. This is just a dual-core netbook. Basically, it's nothing fancy. We're going for as cheap as possible. Exciting. And of course, your standard joystick, because no one wants a robot that can't drive, right? But it also drives autonomously. Big bonus.
Just turn this around. See the camera? Okay. Let me just try it.
Yes, it's completely open source, and we would love you to download it.
Won't waste your time now. I'll have it over on the side, and anyone who wants to see it after the talk can come up and see me. I've got the dashboard. You can see the laser scans. You can see the obstacle map. On the laptop, you can give it a command to go to a specific location like Tony was talking about. And you can see it building maps and everything else. So if you come by afterwards, you'll be able to see it. But yeah, this is official announcement of TurtleBot in public, and hopefully it'll be available soon as a kit for people to buy and then start hacking on.
Grab the mic here.
Hello.
Right in the mouth.
Yeah, this robot, we decided to use a better, stronger frame and then a better suspension system. And we changed it so it's a solid piece, so it's this one won't break in half and it won't have as many issues as the other ones. This one's getting much better to what we really wanted it to become. It's a very durable robot. And it's ABS plastic and there's Lexan covers on it, so it's very light. Oh, Big T.
This is Big T right
Big
here.
T.
Yeah, you feel T head.
On the head.
But it's a very light robot and it's pretty well balanced. And what it does is it can take quite a bit of beating and just kind of bounce back from it. So it can go over a little more obstacles than normal. So
Very-
I'm going to the autonomous on it and all the other things. And then the arms will eventually go up and down. The body will turn and hopefully the head will turn.
Yeah.
It's gonna have eyes. It's gonna have a hand.
I'm not going to get over there. But yeah, we want to get ready for robot games.
It's more of that operator than it is.
But, work in progress.
Work in progress. Very good.
This is Dave the Funky Monkey. That's our own Nick Donaldson's creation. He sold 350,000 of them this year. At the SIG, which meets at the penultimate Wednesday of every month at the tech shop, we've been building something we call the Bug Bot. This is kind of standardizing. So here's the first draft. Basically what we've decided on, thank you, is to use the Arduino processor, and we're using continuous rotation servos, and our goal is to build table bots, which then can be turned into micromice. And so, again, we're meeting the SIG, which is the next to last Wednesday every month at the tech shop. Everybody's invited to come on board with this project. This is the HBRC bug, and as you can see, it's going from one end of the table to the other and back. Incidentally, the servo, the past 4 issues of servo, the Scott McComb article with the Arduino, it fell, covers the same basic thing that we're trying to do. Is it still running? It's good. And so he's on the fourth installment of the article. It's Arduino hardware, software. He's doing continuous rotation servos. Don't put your hand under there. And incidentally, if you're playing around with these things, something you might use is the Wyland leash. When you're developing the thing, you tie it to a string so it doesn't take the full fall. Or you could put it on a little box that's 5 or 6 inches high instead of doing the whole thing. But regardless, this is the HBRC Bug Rev 1. Thank you very much.
Excellent.
So back in 2009, Bob and I went to Japan to go to the IREX robot show, which is the largest robot expo in the world, I guess. While we were there, we saw lots of humanoid robots. And there are a number of people that are doing Robo 1, which is this humanoid competition. There'll be a bunch of people at Robo Games doing it. They have humanoids that are this size that play soccer, they wrestle, they do kung fu. Anyway, Bob and I could not leave Japan without coming home with a robot.
Well, it was Ted that couldn't leave.
Ah,
He was
okay.
like a kid at a candy store.
Yeah, it was pretty bad. So, anyway, it turns out that this thing is just a big box of screws and bolts and brackets and whatever, and it's a huge undertaking just to assemble it. So, it's been one of those things, and then especially when all the instructions are in Japanese. That's the other problem. I don't speak Japanese. I don't understand it. So, there have been a number of people on a message board that have bought some of these robots in Japan and in Europe. That have been working on translating some of the documentation and being able to get it up and running. Anyway, with a mixture of these items, we finally have one that works. Oh, okay. Okay. Bob can talk while I drive the...
So this is like the third version of this, and it's really cool. And that's why Ted said that we couldn't leave without one, even though it was all in Japanese. When we went to buy it, the lady at the store, so now this is kind of his just walking slowly mode.
Okay, let's make him run.
Now he's going to run.
And he can run backwards.
He's going to backwards. And this has got, these are 22 or 24 degrees, I forget.
22 degrees
22 degrees of freedom. And they're really good for playing soccer. When we were in Tokyo, we were actually playing soccer. There's a soccer kick, which is really cool, another one. And then you can do side soccer kicks, too.
Oh, yeah, let's see.
If Ted can remember what the... no, that's a backwards. That's a backwards.
See, I'm trying to remember which one I programmed. Oh,
Well, that's a hop,
that's a button hop.
which is cool.
Oh,
Oh, and
here's
that's
the
just a wave. Yeah.
And then I got another one here. I think this one is the fist bump. Oh no.
Oh. Whoa.
Push up.
Push-ups. The problem is the remote has like, you got 4 keys, but then you've got, 3 other keys. And with the combination involved, you can do all these things. That's why Ted's kind of just picking a key and seeing what he's doing.
Yeah, so that has a programming language that you can program it in, and you can basically play back these pre-programmed moves. And he's got 30 or so moves that I've got in him, and I've spent a lot of time figuring out which button does what. But in true homebrew style, I only got it working today. So I don't even remember half the buttons I programmed. Yeah.
So do the one where he falls down, gets back up. That's cool.
Oh yeah. Okay, so if he fell down, this I can do, I think. So if he falls down, he can get back up.
So Ted and I goal is for Robo Games is I think we have to have 3, right, David? Okay, we're trying to find a third person for our team, but we're going to maybe enter Robo Soccer. So
Yeah, because we have 2 of them, and then Bob also has a.
I have a third one, but it's not. Or I have a second one, but it's not quite the same size, and the remote's not
It's
as
okay?
good. So, is that okay?
We
Okay.
can have a what's the brand of it?
It's a high tech.
It's a high tech.
Okay. So that's that guy. Why don't we show him the balancer and then we can move on.
Yep.
So Ted and I, ever since we met, we've been doing balancers, and we just realized it's been going on almost 9 years now. So this is like our second balancer. And he's called Bender, and he is really, really,
Some people have asked in the club, why don't you guys ever bring a balancer around anymore? It's because we've been bringing it around for like 5 years and it seems old hat.
Right.
And a lot of newer people haven't seen it, so we thought we'd bring it.
You guys been dating for 9 years.
I know.
yeah, well, that's another story. It's bad enough working with him, you know. Like his wife, one day I walked into the office and she says, "How you doing?" I said, "Oh, okay, but I got to work with Ted." And she goes, "Well, I got to live with him." There goes a.
Hold on, I have a remote.
Oh yeah, I didn't see it over there. So I don't know how far the cord goes, but he's one of our more stable guys, and we use him kind of as a test bed to kind of qualify new designs that we're doing.
If I can put him on the floor.
Yeah, otherwise he'll fall down. No, but we balance one balancer on top of another one. That's kind of cool. That's on YouTube. We did that in Las Vegas. Of course, that was a good act for Las Vegas.
So you can't really see it going, I guess.
Yeah, we can demo them afterwise. Yeah.
Hold on a second.
What? Oh, okay, real quick. So somebody else can come up. You can tell he's really dusty. We don't dust very much.
That often. Okay, let's see if I can. It's pretty solid. And we can like kick him. Another thing too, that's interesting. That's the old table test. You can lift
right.
the table and it'll lean up into it. I'm not getting that confident here. Why don't you move that way in case it falls?
Here, let me put this guy over here. Okay, go ahead.
So
yeah, two-wheel balancing robots make a really good base because they can maneuver around real easily, and we even have one that falls down, gets back up. But we haven't brought him in a long time. So anyway, thank you.
My name's Alex. This is a robot that I was just working on a image processing for a Ranger. So I was supposed to get this running today so that I could demo it, but did not get enough time to work on the software on this side to take the data from the Ranger. This Ranger basically provides, it's a triangulation system, and what it does is it's basically able to do up to 30 frames per second of ranging. Right now, it's meant to be used for a firefighting robot application. So the next part will also include some form of a slam inside.
Very good. Where's the laser coming out? Is it, can you put a backstop or something?
I just don't want to put it into people's eyes.
No, but I mean, can you put something behind it that will show us? Okay, so it's about that high?
Right, it's basically about 90 degrees coverage. I've tried different lenses to get it up to 120, and I do have a lens that can do the 120. It's basically a very low-cost device. The whole unit can be built in one piece for maybe $20 or so. And then the output is already RS serial. Currently 115K baud, but you can use higher if you want the higher data rate, or you can use lower if you want a quick process.
Thank you very much.
Hi, my name is Rob Harrell. Just wanted to show off my little robot that I made. His name's Sanjuro. I made it with the Nito Robotics wheels, and thanks for the wheels, and an Arduino. So I was just having fun, basically putting all the pieces together because pretty much all this is soldered together by myself. Tabletop robot. Currently, he should be phase 1 compatible. Let's see if he actually will work in front of a crowd. So he's running around. Sometimes one of the sensors can get a little sticky and doesn't move quite correctly, but he seems to be working well now. So, Sanjuro.
I should mention that when Camp brought the wheels and coders, the next meeting,
3 robots came back using them. It was a record, because usually we hand this stuff out, and 90% of the time it never comes back. But this time, a lot of it came back in robots, which is what we like to see. This is the robot platform I've been working on. It does roll around in my house. The problem is setup takes 10 or 15 minutes because of the way I have to set up Wi-Fi. So it's basically 2 Bainbot motors, which I have modified to have rotary encoders on it. If you folks have been here a while, you know Bill Benson and myself, we do something called Robobricks. Okay, Bill Benson is our secretary sitting back there. And so basically we have a string of modules going along here. I've recently become a convert to ARM processors because they're cheap and they're fast and they're roomy on the inside. So no more 8-bit micros for me. I'm giving them up. Okay. So I have a new 8-bit, 32-bit ARM coprocessor board there, and then it's talking to the rest of my modules. One module does dead reckoning. You just feed into rotary encoders, and you tell it the diameter of the wheels, how many ticks per revolution, and the distance between the wheels, and it keeps track of dead reckoning, does all the math, sines, cosines, all that stuff. And then I have a motor controller board, and that's really all that's necessary to do this. These are just casters. They're omnidirectional wheels that I use to provide casting. And then on this side is an iOmega iConnect. I bought this one for $90 at Fry's. I recently picked one up from Staples for $65. And then we've got an inexpensive $20 webcam. This thing runs Linux, and we can talk to it. And what's really nice about it for me is that I can get access to the serial port here. I didn't even have to cut make a hole in this thing. They had a nice convenient slot for me to put the cable through. And so that's how I control the rest of my robot, was with a serial cable. And then what I've been doing is the reverse of what the gentleman with the little fiducial robots did. I'm putting the fiducials on the ceiling, and I'm letting the robot run around underneath the ceiling. Okay, and I'm getting very accurate angular positions of sub-degree angular readings, and my positioning is accurate to currently within half an inch or so. And this is with a fiducial that's about 8 feet up on the ceiling. And so the goal is for me to put little fiducials around my house, and then this thing can drive around from fiducial to fiducial. But I don't have that working yet. So I'm going to stop now. Also, the reason why I don't like hauling this thing around is it's got a lead acid battery on it. It weighs a ton. Okay. The rest of the platform is really very light. I'm going to shut up for there, and we'll get going with the rest of the talk.
Hi, my name's Layla, and I'm from Willow Garage. I just wanted to mention briefly that you may have noticed there's a bunch of us here. So Melanie, Tully, and James just gave some demos looking at hobby robots. And we actually really are interested in understanding how we could support the hobby robotics community, and that's why we're here. And we'd like to invite you all to maybe share your thoughts with us, maybe spend, an hour and a half for a gift for us to just talk with you and understand what it is that you're trying to do, what needs you have, and how we might be able to support them using ROS and other low-cost platforms. So it'd be great if you would be up for talking with us, and if you are, just go to the back of the room over there, and there's a ballot box, or talk with one of us here. So Brian is over here, James, Melanie, Tully, Ken, Troy was somewhere in the back, Bianca, Caroline, and Tony. I think I got everybody. So we really do care about this community. We'd really like to learn more about you all. So it'd be great if we could talk with you. All right, thanks.